Hi everybody. If you aren't reading the chat, here's how the Q&A session generally works. So every odd-numbered week, so this is week 3, during the lab day, I just have a period available where I answer questions. If you have like homework questions, questions from the text, or worksheets, or lab, or whatever, you drop them in the chat, and I will answer them for you. I go until I stop getting questions, so put any questions you might have in the chat. I'll get to them one at a time. And once I've answered all of them, I'll put out a last call for questions. And we keep doing that until we run out of time or there aren't any more things that people want answered. So go ahead and put anything you want in the chat. I'll check it again in about 2 or 3 minutes, and then we'll get started. See you in a bit. Okay, it looks like I have a little bit to work with here, so let me turn the music down like that. So we'll just go over here. Yeah, that loaded correctly. Okay. Let's see here. So the first question was asked was, so there's this calculation here. So how do you do a calculation like this? Honestly, you just have to punch it in your calculator to get an answer that works. Something else that you could do, you could split up the exponents if you like, and just do the math with those separately. So like 10 to the 6 times 10 to the minus 5 would be 10 to the 1. And 10 to the 1 divided by 10 to the minus 2 would be 10 to the 3. And the gist for doing exponents is if you're multiplying terms together, you add the exponents. So 6 and 5 add together get 1. And if you're dividing, you subtract. 1 minus -2 is 3. And then you just punch the other numbers in. 4.15. So that'd be this part. 4.15 times 2.2. Oops. I held the eraser down for a second. And so I got, for this part, I got 1.301496. And then for this part, I got 10 to the 3, so I just stick that on the end. And then all I have to do is worry about sig figs. So this has 3 sig figs. This is 2. This is 4. So my answer should have 2. So that's how I do that problem. Now, alternatively, you just punch everything in the calculator that you want to. If you are using your calculator to do problems like this, the most important part about that problem is this part right here. Whenever you divide, make sure you put parentheses around anything you're dividing. Especially if you have like an exponent involved or you have 2 terms you're multiplying together on the bottom. Because your calculator does everything in a row. Like if you were typing this in your calculator, you would type parentheses 4.15 times 10 caret 6 parentheses times 2.2 times 10 caret minus 5. And then if you go like this and go divided by, like that, what your calculator thinks to do is it goes, okay, I'm going to do this, then I'm going to multiply that by this, then I'm going to divide that by this, and then I'm going to take the result of this and multiply it by that, which is not what you want, right? Because you want to divide by this whole thing. So you need to make sure that when you are dividing, you put enough parentheses in that your calculator knows what it's supposed to be doing. If you get the wrong answer, that's the number 1 reason why. The number 2 reason would be doing something like this, using the wrong key. On a TI-83, there's a button that looks like a lowercase e. Sorry, it's lowercase ee. And when you push that, that does a times 10 to the power button for you. So typing in like this would be the same as this number. And so that's a feature of just knowing how to use your calculator. If you're using an online solver like Wolfram Alpha, you can just type it in and it'll automatically do it for you. But if your calculator is confusing and you aren't sure if you are doing the correct like command or keystroke, one of 2 things. One, you can look at the documentation. There's always a PDF online of how to use your calculator. You just got to find it. 2, probably easier, take a picture of your calculator and send it to my email, and then I can tell you. I've seen every calculator at this point that I can pretty much find what key you need to push, and then I could just draw a circle around it. So if you need me to do that, just go ahead and take a picture of your calculator and send it to me. Next question. How to tell the difference between defined values, infinite sig figs, versus other values that look defined but aren't? That's really difficult, to be honest. So in this class, oops, I guess I'll go up here. In this class, what I would normally do is give you a formula sheet that has all of the definitions available. So, like, I would write something that would say, and I would include in parentheses, like, oh, it's exact. Or I would say 1 mile, 1.609 kilometers, which is inexact. Or something like that. And so if I were to give you this sheet, I would tell you these things. Online, I would say that your best strategy. So if you were looking up conversions, then assume that they are inexact. That's the safest thing that you can do. Generally speaking, on the quizzes that I give you, with very few exceptions, I will give you a problem, and then the problem will state itself, give your answer to X sig figs. And then you're going to round your results to the number of sig figs I give you. And I have already told you what number of sig figs to use in the calculation, because Canvas doesn't know what sig figs are. And it's an unfortunate truth. Now, you do still need to do sig figs correctly, because if you don't use the rules for sig figs, you're going to fall out of the error tolerance that I allow on the questions. So if you use too few sig figs, then your answer will be too big or small, and I will have constrained the correct answer to a smaller range than you will fall into. If you have too many sig figs, then you get an answer that is too precise based on what you know, and again, you could still fall outside of the error range. So use the correct number of sig figs to guarantee that you will be most likely to fall into the correct range of answers that I expect. Range being like rounding error. I accommodate for rounding errors and stuff like that. Generally speaking, remember that exact numbers are only things that are defined. So an example of defined would be metric to metric. So like we define a kilogram as 1,000 grams. Like we just said that. That's true. Or anything that's counted. The other example that I could use is, I used the word exact. I know one of the problems that you have to do, there's a problem about an half-orc counting his gold coins for Unit 3 or something like that. And I say, he found a treasure chest that contains exactly this many coins. And so that would be an exact number. Then for inexact, that'd be anything else. Particularly because it's measured. So if you don't count it, it's measured. When you're looking up stuff online, it's important to try and consider the context of what is being stated. But that's not always possible. If you're looking up a conversion in Google, just assume that it's inexact. As long as you get 4 or so sig figs from your conversion, you're generally okay. I hope that answered those questions. Oh, sorry, I'm drinking my water here, and I just saw the mic go whoop. I'm like, oh no, everybody heard me swallow water. But I'm thirsty. I must drink more carbonated water. All right. Are there any other questions? Is there a good website that you recommend for conversions? Honestly, what I do when I don't know the conversion for something is I just go to Google and I just type it in. So like feet to, like if I call up Google here, let me see here if I can capture this. That didn't help me any. Hold on. So if you just type in Google, like if you type whatever you want to, So like feet to meters, for example, and you hit enter, what it will do is it will spit out, and I'll make this smaller so that I can do this. It'll show you the conversion that it has. And then what you can do is, if you didn't want meters and maybe you want kilometers, you can actually try any of these other units, and it will do that for you. You can just play around with it. And then what else you can do is you could then, I don't know, maybe you want to do inches to meters or something like that, or feet to miles, and it will tell you. There you go. So stuff like that. So Google's really good for these sorts of things. It's not really possible to know from this page specifically what is exact and what's not. For example, I know that miles to feet is exact because that's a definition, but just looking at that, you wouldn't be able to tell. I think Wolfram Alpha might also do the same thing. So if I gave you something like the furlong, and if I say that this is an exact definition, it won't affect your sig figs. If I don't say that, or I say it's inexact, then what you do there is you use the sig fig rules that we have been applying all quarter. So for that specific number, if I said that 1 furlong equals 0.125 miles and that was it didn't say that it was defined, you'd say, oh, okay, there are 3 sig figs written. Does this affect my answer? And then go on with that in mind. I know we can't see the answers on the quiz. Is it possible to see what your score is out of 10? No. The whole point of me hiding your quiz scores is to avoid students taking a quiz, getting a score, realizing they did well, and then telling those answers to other students. So, in the interest of equity, no, you don't get to know your score before you take the quiz because everybody is not taking the quiz at the same time. If you are not sure whether you did well on the quiz or not, take it a second time. Ideally, you should be able to do the quiz and go, okay, I feel like I did well on it. I don't need to take it a second time. I do realize that as students, points are everything to you in the world. I wish that I didn't have to say that, but it is true. You guys will do literally anything for points. But in the interest of fairness, I know in previous quarters that I would have like the one friendly student who was also great at the class, and they could answer the questions and maybe screenshot all of their answers or whatever, and then say, oh, I got a 10 out of 10, so I know all these answers are right, and then pass those answers around to everybody. This has happened. I know that it has happened. There's nothing I can really do about it, but I can put obstructions in the way so that it makes it less practical, and this is for those people. I want to know what you really know, and so it seems unfair that why can't I know my score? Well, that's why I have to do it. It's because of academic dishonesty. You get your score back when everybody else does, and then the answers are revealed. And unfortunately, that's the best that I can do. It'd be kind of like in a real class where you do the quiz in class, you hand me your papers, and then I take all the papers away and then I grade them. Is there a study guide for the test? Use the worksheets that I have posted. If you know everything on the worksheets, you will know everything on the quiz. Also, all the slides that I made. Honestly, in college, I would say that the best thing that you can do is to take all the material that you've covered and make your own study guide. Because you should ideally be able to look at the worksheet for Unit 3 and be like, oh, okay, here are the questions that I should be able to answer. I should know how to convert from metric to imperial. I should know how to do a story problem, like that sort of thing. So those are things that you could write down. I feel like if I write it down for you, then it just becomes a checklist. Other questions? How do you define a color that is transparent? Color and transparent are different qualifiers. So a color would be like red, orange, yellow, green, blue, purple, that sort of thing. But transparent is an opaqueness. So you could describe a liquid as red and transparent, which would be like red Kool-Aid that you could see through. Let me get a picture, actually. That's the best one. Red and transparent. So something, let me see here, like liquid. I'm trying to find an image in Google. And now I've just got my screen is full of like splashes of red goop that look like blood. Red and transparent juice. Let me try fruit juice. None of these examples are very good, though. And I'm coming up with nothing here. So transparent means that you can see through it. As in, like, there would be a picture behind the liquid, and you could see the picture. Yeah, let me try typing in apple juice. Yeah, all these pictures of apple juice that I'm getting are opaque. Or there isn't something behind it because it's like clip art. Oh, I haven't even tried the most obvious thing. Transparent versus opaque. Yeah, here's a good picture. This isn't for solutions, but I can do this. So if I capture the window now... Oop. Oh, that didn't quite work. So if something is transparent, you should be able to see stuff behind it through it. But if something is opaque, you can't see through it. Translucent is sort of just the middle region of that description. We're not going to use translucent as a description in this class because it's a little too hard to determine whether something is translucent or transparent. Like I could barely tell from this picture here. But if you are looking through a solution and you can't see through it, it's opaque. Now, I realize that I put a piece of paper in the lab behind the test tubes. And so what you need to look for on that, if you use translucent, that's fine. I will interpret translucent and transparent as the same. But if you cannot see through the solutions, for example, I put a piece of paper in the way, what you can do is you can look at how light passes through. So like the transparent or translucent solutions, light will pass through it and you'll be able to see the light on the back of the paper. Whereas for the opaque solutions, you can't. Let me see here. Just really quickly about requesting access to the Google Sheets. Review the directions for how to access lab. We covered that in the Wednesday lecture last week that I posted. That will show you how to access Google Sheets. You need to save your own copy. If you send me an email for a request, I delete it because you can make your own copy of it. What else do we have? 355 centimeters cubed to inches cubed. We can do that. Oh, shit. Hold on. It's asking me, do I want to delete things? I don't want to delete over there. I didn't click on Photoshop. I'm deleting things from my OBS, which would be no good. So we did this one during lecture, so you could review this in what we did yesterday. What are we doing? Centimeters cubed to inches cubed? Yeah. So I know that in an inch there are 2.540 centimeters because I can look that up on Google. But I want centimeters cubed, so if I want to do that, I have to cube everything. And so I'm going to just put those conversions in. So I have centimeters and inches cubed. And then I'll just put in the numbers. This cubic centimeter, because it's going to get cubed because of this 3 here, will cancel with this cubic centimeter. And I still have to cube this number. And then this 3 will go in here to both these. And so then I just punch it in the calculator. And I get 21.7 inches cubed. Which should have 3 sig figs because the number I started with had 3 sig figs. There you go. Did I miss anything in here? That was all the transparent, translucent. Oh, you know what I could do? Ha ha ha. Here's what I'll do. I could just draw my own. So, let's suppose that here's my background. I gotta make the brush bigger for this. Alright, so here's my brush. I'm gonna just do this real quick. Actually, you know what I should do? I should do a different color here. Because you'll be able to see this. So if there's no color, write colorless. Like something that looks like water, you just write colorless. Alright, so here's gonna be my background here. And then what I'm gonna do is I'm gonna make a new layer. And then we're gonna put in blue. So if I draw like this is opaque. I can't see the yellow through the blue. But if I do this, watch this. Ooh. Now I can see the yellow through the blue. That actually didn't work as well as I had hoped, so I was hoping it would look kind of green in there. But I have this bar where I can just change the opacity. Yeah, like a highlighter over words on a page would be transparent. Because you don't obscure what you see. Delete layer. Boop, boop. Oops. Boop. Yeah, so in that color field, if you are asked to describe the color of the solution, but it looks like water and does not have a color you could ascribe to it, just write colorless. Don't write clear. Clear is not a color. Clear means transparent. That's really what I'm checking for is, are you using clear as a color? because that's not clear is a definition, or clear is a description of how well light passes through a medium. Are these conversions considered dimensional analysis? Yes. So all of this sort of... Oops, that's the wrong size paintbrush. Hold on. 4. There we go. Any sort of unit cancellation is dimensional analysis. Because you can think of units as dimensions, and you are canceling out one unit to another. We can do a problem, but you'd have to provide an example for me in reference. So I can't create a problem, because what I will end up doing inadvertently is creating the quiz problem, which I don't want to do. So you had to provide me with an example to go over. Do you have a different problem? Because remember, all of these videos are online. You could go back and watch that video again. I would much rather go over new problems. Like, if you have an example from a textbook or the worksheet or something like that, let's do that. But let's not do lecture problems, because I've already done them, right? Like, there's a problem, and I think that might be from the worksheet, so we could definitely do that one. Let me scroll this down. Let's use our time wisely here. 17.90 pounds. That doesn't really look like a 7, does it? Per square inch. So I have pounds per square inch. And I want grams per square millimeter. That air problem, I believe, is also in the lecture. But this pounds to square inch one definitely isn't. So we can go pounds to grams directly. This is 1 pound equals 453.6 grams. And then inches to millimeters, we could definitely do inches to centimeters. So 1 inch, 2.540 centimeters. And then you could go from centimeters to millimeters. That's, I mean, this is not a recommended conversion. But it's true, and you could use it. I would prefer to go from centimeters to meters to millimeters, but this will be okay for this example. So let me set up all the units so that we can cancel them out here. Let's start by getting rid of this pounds first. So we'll turn pounds into grams. And then what I'm going to do first is I'm actually going to try and slide this over so I have more space. Okay. So pounds to grams I can easily do. I'm going to just fill in these numbers when I get there. But then what I want to do is I want to get rid of this inches squared here. So I'm going to put inches squared on the top. And then I'm going to put whatever I'm going to convert it to on the bottom. So centimeters squared. So inches squared will cancel with inches squared. And then we'll do the same thing for centimeters squared and millimeters squared. So that centimeters cancel out. And now you just fill in the numbers. So 1 pound was 453.6 grams. 1 inch was 2.540 centimeters. So that's good. And then there were 10 millimeters in the centimeter. And again, I'm just doing that because that's a really trivial conversion. Normally, you would not want to go from one metric prefix to another. You'd want to go through meters. Like, I would not know a conversion from kilometers to meters. I'm sorry, kilometers to millimeters. I would go through meters to do that. So the units that are going to be left over are that and that squared. And so now we just punch it all in the calculator. 17.90 times 453.6 times 1 squared times 1 squared divided by parentheses 2.540 squared times 10 squared. Close parentheses. I got 12.585157, which I'm going to round to 4 sig figs because this is 4 sig figs, and so does that. Everything else is a 1. This is actually exact, but it also has 4 sig figs, so you get the same answer anyway. So that should be the answer. All right, let's do this next one here. So, yeah, this is a new type of problem. What is the volume of 100 grams of air if its density is 1.3 grams per liter? We technically haven't done density yet, but we're going to do it tomorrow. So this is close enough to then that we could do that problem because density is just the relationship between a mass and a volume. And so if I know that the mass of air is 100 grams, then I could set up the units between mass and volume and just cancel them out like that and get a volume, right? So 1.3 grams would be 1 liter of air according to its density. So 100 divided by 1.3 would be 76.92, which I would have to round to 2 sig figs here. So 100 grams of air is 77 liters, which seems absurd, but air is not very dense. Like, if you fill a 2-liter bottle with air, it weighs less than a wheat thin. The air inside, anyway. Now I'm eating the grapes on the bottom of my drink here. All right, let me hit clear again. So worldwide emissions of CO2 are 2 times 10 to the 9 tons per year. It's a lot of tons. Maybe we should stop polluting so much, but, you know, people don't learn. What is the emission rate in pounds per hour? So I have tons per year, and I want pounds per hour. Now, the only issue that I can really think of with this problem is that I don't know if it's a ton, which is 2,000 pounds, or if it's a metric ton. I'm going to assume that the ton in question is this. And not, say, like some other ton. Because there are a ton of different tons, it turns out. But 1 year is 365.25 days. Since we don't know if it's leap year or not, we'll just take the average. And then 1 day is 24 hours. So let's do this. Just move this guy over. So I didn't unselect. Hold on. So I'm going to set up my unit so that these cancel. We'll start with tons here. So tons goes on the bottom. We're going to turn that into pounds. And then we're going to turn years into days. And then days into hours. These are the only units that are left, so those will be the units of my answer. And then we just fill in the numbers. So 1 ton is 2,000 pounds. A year is 365.25 days. And then a day is 24 hours. Let's punch in the calculator. 2 times 10 to the 9 times 2,000 divided by 365.25 times 24. So we get 3678. 4 point. Oh, I only get 1 sig fig here because this number is 1 sig fig. So I get 5 times 10 to the 8, it looks like. 3678, yeah. So 5 times 10 to the 8 pounds per hour. Or in other words, 500 million pounds of CO2 are made every hour on Earth. 500 million. Is it time for that Green New Deal yet? Or are we going to just keep doing what we're doing? Because it's starting to get a little hazy in here, right? Now, to be fair, the amount of CO2 that is eaten by trees is probably on a similar order of magnitude. So there are a lot of trees out there and a lot of plants. And so they would eat nearly all of that, but not all of that. We are slowly accumulating CO2 in the atmosphere. If you want to know more about that, you can look up the CO2 readings at Mauna Kea. I think it's Mauna Kea, or maybe that's the volcano. There's a, let's see here. CO2 atmosphere levels. Mauna Loa. Mauna Kea must be the volcano. Is hazy a valid description for solutions? Yeah, I think so. I would describe hazy as like kind of the midpoint between opaque and transparent. Like you can see something through it. I don't know why this website isn't loading. How about this one? None of these are loading. I can't actually get to noaa.gov, which is kind of weird, but that's all right. Francisco weighs 244 pounds. Do you? Are you just did the problem actually have your name in it, or is that a coincidence? They took a break for inauguration. I mean, you weigh less than me. I weigh like 260. Which apparently is not that big because I like jump around like I don't know, a person that's heavy and jumps around. I don't feel that heavy, so I'm also 6 foot tall. And so what do I got here? 244 pounds. And I want to go from pounds to kilograms. 1 kilogram. I'm gonna just look this up. There you go. So straightforward conversion, just punch in the numbers. 110 kilograms. Oh, that rounded to 111 actually. So there you go. I'm trying to lose weight, but it's really hard during a pandemic. I think it was like 260 last time I checked. I remember when I was in college and I was like, man, I weigh like 190 pounds. Like that's so many pounds. And then I started to like drink beer a lot. We'll say. But I'm also not convinced that all of the weight that I've put on since then is just like fat, because I say this while I'm eating, which is very telling, but I'm eating grapes, so like I do a lot of lifting things and moving things around, and apparently like I am the strongest of all my friends by far. I keep getting recruited to help people move things. So it's like, okay, I guess I'll help you move your house out because you know you had a month to do this and your lease ends tonight. So sure, I'll help move your barbecue and your couch and all sorts of this stuff. Anyway, I get over to to friends' places and they're like, "Okay, who's the strongest person here?" And everybody looks at me like, "What?" So apparently I'm like half muscle. I don't know. Muscle is very dense relative to fat, so if you have a lot of muscle, you can appear smaller and have a higher weight. So weight is just a number. Don't worry about it. My number happens to be quite big. What is important is that you are happy and feel healthy. So how many gallons is that much water? So how much water we got? We got 3.0 times 10 to the 5 milliliters. Then we've got, so we got to go from milliliters to gallons. So we can definitely do this. So a milliliter is 10 to the minus 3 liters. And then I don't know how many liters there are in a gallon, so I gotta look that up. It's like 3.7 something. Gallons to liters. 3.7854. So 1 gallon is that many liters. And so you should be able to just do the dimensional analysis. So milliliters to liters, liters to gallons. Boop, 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 boop. So 1 milliliter, 10 to the minus 3. And then 1 gallon, 3.785 liters. Punch it all in your calculator. And that is 79 gallons. It's a lot of water that we use per day per person. I do not think that I use more or that many gallons because I live alone. I don't do dishes every day. I don't do laundry every day. I don't use the toilet 70 times a day. Definitely the showering part, though. I sometimes shower twice a day because, like, I'm cold. That's really why. Like, what's the warmest thing in my apartment? Oh, hot water in the shower. But I also shower every morning, so, you know. And that water adds up really quickly. Alright, we'll do one more and then we'll take a break. So, this one is an acceleration. Can I just... Oh, there's nowhere to put this stupid panel. I'll just do that. There we go. I have this panel for Photoshop that I have to have up because I use it, but it gets in the way of what I'm writing in. So 1,800 kilogram meters per second squared. And I want to do pounds, miles per minute squared. Oh, actually, you know what I want to do here. So that's my target unit, actually. Let's put you down there. I don't know why it thinks I'm applying a transformation. Oh, just stop. There. All right, so I have kilograms, meters per second squared. So seconds to minutes is really easy. 1 minute, 60 seconds. We can do that. Meters to kilometers to miles is no problem. And then kilograms to pounds is, well, I was going to go to pounds, but I veered to the right there. So 10 to the 3 meters equals a kilometer. 1 kilometer equals 1.609 miles. And 1 kilogram equals 2.204 pounds. Now, we've done a lot of these problems today, and you've seen me do a lot of dimensional analysis. So here's what we're going to do to solve the problem. Dun, dun, dun. You're going to solve the problem for me during the break, and then we'll go over the answer at the end. So I want to see an answer in the chat box, and I want you to use what we've been doing all along to set up the problem and solve it. Now, you can always rewind the video, and you can look back at the other problems that we were just doing. But we are going to go over the answer. I just want to see if you can do it. Okay? So I'll start the timer. We'll put the music up. Keep typing questions in the chat. And when we come back, we'll go over the answers. I got to find the music. Where did it go? Oh, I have this new tab in the way. That's why. Okay. What do we have here? Yeah, here we go. Alright. Let me wind the music down. So I got an answer in the chat there. Let's do the problem and see if that's the right answer. So if I'm going to set up my units, I'm going to get rid of kilograms first here. So we'll do that. We'll turn that into pounds to match up with the target unit here. Then I'm going to get rid of meters by turning it into kilometers. And then I'll turn that kilometers into miles. And then I need to get rid of the seconds down here at the bottom, so I'm going to put seconds on the top, but it needs to be squared. So we'll turn that into minutes. So those seconds squared will go away with this second squared. Now I just fill in the numbers. This is the only unit that's left, and those. So my answer will be in pounds, miles per minute squared. All right, what do we got? So 1 kilogram is 2.204 pounds. Kilogram or kilometer is 10 to the 3. A mile is, a kilometer is 1.609. And then there are 60 minutes or 60 seconds in a minute. There we go. I'll punch it all in. Let me see what I get. $1,800, 2.204, 1.609, 60 squared, over 1,000. Times 1 times 1 times 1. Okay. 22979.6 or 23,000, it looks like. To 2 sig figs. There you go, you both got it right. There you go. You are all set for dimensional analysis, I think. So we've done a bunch of story problems. We've done a bunch of conversions. Where are you getting these problems? So remember that a milliliter is the same as a cubic centimeter. So that's not going to be very difficult to do. And then if you want to do cubic feet from that, then you can do that. Really, the trick to doing these problems is do these blueprints. Until you can identify what you are seeing and how to do the conversion, do the blueprint every time. Because you can see how quickly I just whip right through these problems, even doing the blueprint, right? And ideally, I would like you to go this quickly. Obviously, I'm not going to make you do that fast on the test, but it won't be that much slower. I can assure you that. All right, we'll cancel out inches to get feet. There are 12 inches in a foot. This will be the unit that's left over. And we'll punch it in and get 375 divided by 2.540 cubed times 12 cubed. And I should get a really tiny number, 0.13. 0.013243. So 0.132. There you go. There's your 0.01 cubic feet of heroin. And if there's a drug that out there that you should not do, it's fucking heroin. Don't do heroin for... Jeez, no. Do a nice drug like caffeine. Caffeine's a good drug. All right, other questions. Oh, we've run out of juice here. Juice in quotation marks. But yeah, if you have any other questions, I'm just questioning your source, not the questions. The questions are good. Anyone else, let me know. I'm going to hit mute for a second, and I'll check back in like 2 or 3 minutes. Just post any questions you might have in the chat. And if there isn't anything, we'll call it a day. So, see you in a bit. I'm trying to find that question on Google, and I can't find it. I can tell you that the channel is up. It still works. If you have made an account... Oh, okay. that would be why I couldn't find it. I was like, what? What the hell? Okay. Are you using the Discord app, or are you using the Discord in the web browser? Because if you had an account that you didn't register with a password, you should be able to get back to the chat. I don't know how... Because I have the app on my phone, I also have the app on my PC, and it works fine on both of them. I have not experienced that issue. My best advice would be to reinstall the app. which is not great advice, I realize, but... All right, last call for questions. Anybody got anything else they need from me? All right, then I guess we'll call it a day. I want to thank everybody for coming out to the review. We do have these from time to time. Every other week is a lab, and then on the weeks that aren't lab, then I just do this. There will be one in week 5, which I expect will have more activity because the exam will be coming right up after that. But keep those questions coming. Send them to me over email. Throw them in the Discord. Answer other people's questions. Work together, because that's how we get through this class successfully. Have a good night. I will see you tomorrow for the remainder of Chapter 3. We're going to do Chapter 4 and Chapter 5 all together. It'll be quite the day. See you then.